Hi, my name is Frank Morton, Director of Research and Development for Haydon, Kerk, Pittman, a business unit of AMETEK. I'd like to take a couple of minutes to introduce you to a new product offering that we have called the MiniSlide. Common applications for the MiniSlide include laboratory instruments such as benchtop equipment for spectrometry, microfluidics and imaging, optical and inspection equipment, and sample handling equipment. Medical applications include fluid dosing applications, imaging and scanning applications, and many other applications where a compact yet affordable motion control system is needed. The technology used in MiniSlide is based on many of our core competencies that are integrated together into a small, customizable, and convenient slide assembly. Let's take some time now to detail those components. These are some examples of our MiniSlide assembly. It combines our lead screw and nut technology along with our guide rod and stepper motor to create the MiniSlide. The basic assembly consists of 2 cast aluminum end plates, a stepper motor, precision rolled stainless steel lead screw, integrated nut and bushing assembly, and 2 guide rods. Now I'd like to go into a little bit of detail about some of the different components of the MiniSlide assembly. There are 2 different stepper motors that can be used on this product. The least expensive is our 4th generation of can stack motor, which is about 20 millimeters in diameter and can be seen on this slide here. This stepper offers either 7.5 or 15 degree step angles, various winding options, and comes standard with an integrated connector, or it can be configured with flying leads. Second motor option is our size 8 hybrid stepper. This actuator has a 1.8 degree step angle, which makes it ideal for finer positioning applications. It's also configurable with different winding options and even a rotary encoder if position feedback is required. The backbone of the MiniSlide and the guiding surface is a pair of precision ground 6mm stainless steel guide rods. These are also available with a Kerk TFE coating to reduce friction and increase life. The next component is the lead screw. The lead screw is used to transmit the torque of the motor to the carriage, where the threads convert this rotary power into linear power. The lead screws used on MiniSlide are all made of 303 series stainless steel. There are 9 different leads ranging from about 0.3 millimeters or 12 thousandths of an inch per revolution, all the way up to 8 millimeters lead. All of these can be supplied with grease or Kerk TFE coating to reduce friction and increase life. The next component is the carriage. It is a molded acetyl block that acts as both the guide bushing and the nut, providing several different mounting options to which your load can be attached. These will be discussed a little bit later on. Next, we will talk about some of the different design features that make this assembly easy to use and customize for your application. The end plates are the small aluminum blocks at each end. You'll notice there are machined surfaces on these that can be used as reference planes or to add drilled and tapped holes. The standard configuration has 4 mounting holes on the bottom plane. These can be either M3 or 440 threads. These pads will also accept up to a 5mm diameter thread. The end plate opposite the motor, you'll notice, is also a shorter height. It's 1.1 millimeters below the height of the carriage, which allows the load to overhang on that side. This can also be ordered with a full height end plate in case additional mounting holes or features are required. The carriage is another piece that offers a lot of flexibility. For mounting the load to the carriage, there are 3 different options. The first are these 4 counterbore holes. These holes are designed to accept either an M3 or a 440 socket head cap screw. The second option involves a molded thread insert, an M3 thread to be exact. And the third option is a 440 thread. The intent for these is for the screw to engage from the counterbore side into that thread, pulling that insert into a plastic shoulder to provide a fail-safe locking condition. You'll notice some coring. This is done to optimize the mold flow and to help provide a very flat surface for mounting your load on top. There are also 2 holes that go through the middle of the carriage. This provides coring for mold optimization and can also be used for dowel pins if additional strength is needed to secure the load to the carriage. We talked about the different stepper motor options that are available, but the orientation of these motors is also something to be customized. For the 20mm can stack motor, the connector can be mounted at either the top or the bottom location. For the size 8 hybrid, it can be mounted with the wires to the top, bottom, right, or left of the rail assembly. In the case when an encoder is specified, the convention is to have the encoder wire exit on the same side as the motor wire exit. The MiniSlide has a low flyover height, or height from the top of the carriage to the mounting surface of 17.4 millimeters. It is available in strokes up to 100 millimeters in length. You will note that there is about 3 millimeters of additional stroke length built into the standard assembly. This allows a buffer so that you always get a minimum of 100 millimeters of stroke, and it also allows a 100 millimeter stroke MiniSlide to fulfill a 4-inch stroke requirement. The design payloads and moment capabilities of MiniSlide can be seen here. For reference, when referring to a roll moment, we're talking about a moment that would influence the carriage to rotate about the axis of the lead screw. A pitch moment would act like this, and a yaw moment would rotate the carriage in this direction. For instances where the moment loads are light, longer strokes up to 150 millimeters can be considered. Next, I'd like to show a couple examples of some simple applications for the MiniSlide. In this case, we took 2 MiniSlides, one with a can stack, one with a hybrid, create a simple base plate. This was for a sales sample, so it just has spring pins, but in production you could use fasteners to lock these 2 together. With the addition of that simple base plate, you can create an XY stage very quickly and easily. Another application I'd like to highlight is a MiniSlide inspired 3D printer. In this case, there are 2 MiniSlides, one at each end, used for the ZAxis. You can see the end plates are mounted to the base plate. An X stage and a Y stage. Both those are mounted on edge, which is a little bit of a unique configuration with the rails mounted vertically here. That allows it to traverse across the entire span with less deflection. You'll also note that the end plates here and here from these MiniSlides have incorporated end-of-stroke sensors into the mounting features available on those end plates. For more complete technical details, please visit our website at www.haydonkerkpittman.com. There you'll also find drawings, 3D model downloads, and contact information. Thanks for watching.